Hey everyone, welcome to Creative Digressions. This is your host, Akram Ahmed. Today we're going to chat about something fun, recursion. So, introducing Exhibit A right here. Let me actually grab this and bring it in a bit closer for you to look at. So you will see in this original frame, this print here has a robotic arm drawing a human arm, and the human arm in turn is drawing the robotic arm. How about that? So this is a gift from a good friend, a distinguished professor over at the University of California at Berkeley in the Electrical Engineering and Computer Science Department, Edward Ashford Lee. It's a gift from him. And this print actually graces his book, the cover of that book published by the MIT Press. So you'll see here the same drawing hand, right? And this book is called Plato and the Nerd, the creative partnership between humans and technology. It's a really, really good one. And I will definitely drop a link to it right here in the video description so you can check it out. So what exactly is recursion, right? So I've been doing a fair amount of hand waving already by saying that look at it visually. This hands drawing each other, or I guess if you want to go this way, counterclockwise. But the idea of recursion is really quite simple. It's a way of solving a problem by breaking it into smaller versions of the same problem, right? It works by having something call or repeat itself, but each time on a simpler case. And a common example is set of nested boxes, right? So you have a big box, within it is smaller, and within it, and then within that, and then, you get to the smallest box ever, and you keep going until you get to the smallest one. And there you have the solution. So this is a bit more conceptual, but what does it do for us in real life? Glad you asked. Recursion has been actually realized in a programming language called Lisp. So I'm going to go ahead and grab this title. It's a really, really good one, a classic in the field. And it's called simply Lisp by Winston and Horn, an introduction to the language and its applications. So John McCarthy over at the Stanford University Artificial Intelligence Labs back in the 50s, I think mid-50s, he created this language to solve pressing problems that were proving to be a thorn in the side of programmers everywhere. And they held a big conference, and the Lisp language came out of that symposium or conference, whatever it was called. I didn't really look up the references, but I invite you to do that. And Lisp. So Lisp is short for list processor, although people have taken the liberties of calling it, let's see, lots of irritating superfluous parentheses, because everything is expressed as a set of parentheses. And the syntax definitely takes some getting used to. It's kept up with the ages reasonably well. Practical Common Lisp is the, I should say, swan song for Common Lisp, in the sense that this is a bold declaration that Common Lisp can and will have a place for itself in the world of programming. And believe it or not, the Java ecosystem, Java runs on the JVM, the Java Virtual Machine. So they saw the beauty and power of Lisp, what it has to offer. And Rich Hickey, he came up with this beautiful language called Clojure. And this is a good one. I don't have much time anymore. I wish I did. But if I had cycles, I would go and check out what Clojure has to offer you. But do appreciate this bonsai tree on top of it. So where else do you find recursion? It turns out pretty much everywhere in nature. For example, let me bring out this set of prints that I picked up from a local Barnes and Noble, and may our brick and mortar bookstores stay alive and kicking. So let me bring it up here just so we can take a interesting look at this. Remember, we saw this? The drawing hands? Yep, there it is. And right there. Yeah, the drawing hands. So we have this amazing brilliance of MC Escher on full display. So this one is called Band of Union. Wow. This one knocks me out. This is beautiful. Yep. So that's this. And then print gallery. So as you can see, this young man is taking in the art gallery, and the gallery is morphing into this place in the imagination of the visitor. And then this one is waterfall. It's a rather peculiar optical illusion, but there's a bunch more. If you folks like, we can definitely hit this again. But for now, I will save it here, but in the future, we can positively pick it up. What else? Yes, right here. Gödel, Escher, Bach. So if you can think of it this way, if there was a single book written to sing the eulogy of recursion, its beauty, like its love song, this would be the book. It's a pretty hefty one, as you can see. I used to be in the habit of putting up these tape flags, and I know a few other people do the same. I don't do it much more anymore, but anyway, this is a specimen from back when I used to. So this guy, Douglas Hofstadter over at the University of Indiana, one of the pioneers in AI. So he won a Pulitzer Prize for this work. And he is a brilliant computer scientist, but he goes well beyond the mechanics of computing. He looks into the gestalt, the spirit that lives in computers, and that really excites me. As you know, obviously, I'm your host here at Creative Digressions, but I've also been the impresario over at Programming Digressions since 2014. And that's a blog post, and it's kind of dedicated, not kind of, it is dedicated to the spirit that lives in the computer. It's a celebration of the joys that can be found in programming. So if you ever thought that programming was boring, that's not the case. No, sir and madam. So this book has a lovely subtitle, A Metaphorical Fugue on Minds and Machines in the Spirit of Lewis Carroll, right? So there's another wonderful writer right there, Lewis Carroll. Here it is. So I think I didn't tell you we're going to have some fun today. Lewis Carroll. I mean, this is ostensibly a children's book, but when you read it, it is a grown-up's book just pretending to be a children's book. It's beautiful, beautiful. We can definitely do a whole program on this alone. So we leave it here for the future. And I was going to say one more thing. There is this matter of the rocket. Now, did recursion help launch a rocket? Maybe the Apollo program had something to do with recursion? Not sure exactly, but I can tell you that Lisp, in its early realization, helped give humans this ability to extend their reach way beyond what computing and the languages du jour of the 50s leading up to Lisp had to offer. So Fortran obviously was there, formula translator, but Lisp really gave computer scientists this ability to scaffold their thinking, precept upon precept upon precept, building this amazing, colossal juggernaut that continues unabated, right? So the most powerful representation of that progress to my mind anyway, is the large language models. Those are just some of the most amazing and complex creations of the human mind. They just blow the mind. So it's a race ongoing between OpenAI, Anthropic, and other players, but large language models are here, and they're going to be a ever more present fixture of our society. Shall we call it wraps for now? Or should we? There was a little bit of a stack here, like a list, but it's adjacent sibling, the stack. So in the future, if you're interested, this sort of thing really excites me. Philosophical questions, not tautology. It's said about tautology. I haven't looked up its definition, but I think I wish we had a lawyer on hand. They could help us disabuse ourselves of this notion and help us understand what exactly is tautology. But as I remember it, it is a thing defined in itself, or it's been said, in fact, in a new hacker's dictionary, I remember now, published by the MIT Press. And the definition they say, if you go to the entry for recursion, it says recursion, see recursion. Aha. So the definition tells us to look here. And over there, you see it says see recursion. So we come back here, see recursion. And then, so it's kind of a little song and dance, but trust me, I've done some hacking with Lisp, not common Lisp. I've read up this lovely, it's a fabulous book. I had it right here. Didn't I show this to you? This is a good one. Yeah, this one is what I had in mind. This is Practical Common Lisp. So this is the one that really excited me. So its author, I believe it's Peter Siebel. So he says somewhere, maybe on the back cover of the book, that he is either a writer turned programmer or a programmer turned writer. So there's a little bit of a nod to this whole notion of recursion, being defined in terms of itself, the drawing hands. And this way, if you want to go clockwise, but right there, recursion for you. Yeah, so I was going to say, leading up to all of this was my thinking that Clojure. Okay, so I've done a fair amount of hacking in Clojure, nothing that I've deployed to production. But yeah, what else I was going to show you? Oh, wait a second. This does not have anything to do with recursion. That's, I think, a nice digression. So we leave that for a future chat about the cuisines the world over, including evidently starfishes. And I think that's gonna wrap it up for today. Hope you had some fun. Drop your thoughts in here, and we'll talk a bit more about this beautiful rocket. Okay, tell you what. If you see that rocket, let me bring this in close. One of the series of books I grew up with. If you see here, I'm gonna try to bring this closer to the camera. See this rocket on the launch pad? And then the same rocket landed on the moon. Yeah. So this is obviously predating SpaceX and the ingenious technology that Elon Musk and his team deployed to make SpaceX happen. But back then, rockets were essentially multi-stage or not, but they had to be considered disposable, but not anymore. So the rocket goes up and then it comes back and lands on the very launch pad from where it had sprung into space. And with that, I hope you enjoyed it. Drop me a comment and then we'll pick it up next time. All right. Thank you. Always a delight.